of the market value of the firm. You see why later. It will be plainly clear. And why is that? What about the second proposition? Here they say that the cost of capital is unaffected by the capital structure. Hey, by the way, when we talk about cost of capital, once again, please make a note of that. We refer to the weighted average cost of capital, the combined cost of capital. Not sometimes we say basically the cost of capital, and we mean the cost of debt capital. Here we talk about equity and or debt capital, any capital available to the firm. Okay? Alright, so the cost of capital remains constant as capital structure changes. Okay? Why is that? Well. As the quantity of debt rises, as we borrow more, the return demanded by shareholders tends to go up. Because they say that, okay, that company has just borrowed money, so they have more capital available. And we would expect from them to make a good use of that money. Quite reasonable, right? We would all expect that from a company that has got a loan from a bank. So we would expect from them, we raise our expectations, we would expect from them to make a good use of that money, of that capital, of that debt, and of course that good use would be expected to generate cash flows, returns, for who? For the company and for the shareholders. So the more they borrow, the more they borrow, it says over here, the return demanded by the shareholder increases, exactly to offset what? What to offset? Actually two things. I'm going to mention them right now and then once again later, when using my numerical exam. So, that higher required rate of return for shareholders is going to offset two things. The first thing is the fact that you have more capital to play with as you wish, for the benefit of the company, of course. Okay, so the first thing is that greater flexibility that you have available now without more with these higher borrowings that you have. And the second thing is the lower cost of debt, which is likely to happen. Now, the more we work, the more that we borrow, then that will tend, on average, based on your credibility, all the stuff, okay, on average, we tend to reduce the cost of the cost of capital. I'm not saying that, if I borrow at 8%, that will be 7.8 or 7.5. I'm not saying that, no. I'm talking about the weighted average cost of capital, okay? Alright? I mean, I'm talking about about the cost of debt in general. The cost of debt is interest charge, interest rate, and my debt coverage. So the debt coverage might be more lenient, more flexible, granting me the company greater flexibility as well. Okay? So on the one hand, I benefit from that lower cost and from the higher capital cost available, but on the other hand, these benefits tend to be offset by the higher expectations of the shareholder. Okay? That is a great commitment. It's not fun. I have to make good use of that money. Otherwise, I'm doomed. Okay. But I'll come back to that point, the second point later as well. That is why you see there, the more you borrow, as you go to the right, okay, the equity return goes higher, expected return goes higher, because they expect more now, okay. The cost of debt remains stable, constant, broadly speaking, as I said earlier, and the weighted average cost of capital, the yellow line, K8, also remains unaffected. We have that offset. So Miller and Modigliani say that when you have no taxes, this type of situation here, then the capital structure is irrelevant regarding proposition number one, regarding your term value. in proposition number 2, the cost of capital remains unaffected. Okay. Now, how things change when talking about taxes as well, in a more realistic situation. Well, let us see. This is with zero taxes. Let's see first the formulas, okay? This is the first proposition. The formula for the first proposition without taxes. We're still in the no taxes situation, okay? Let us have a look at the formulas first. You see, without taxes, the value of those firms is the same. We have equality. So the taxes is irrelevant. VL is the value of the levered term, and DQ is the value of the unlevered term. Proposition number 2. The proposition number 2 shows the return of the share capital S for the levered term. What is the return of share capital for the levered term? Well, that should be equal to KHQ. KHQ is effectively the return of the share capital for firm Q, for the unlevered term. Okay? Plus nothing. Plus the same figure, minus the cost of debt, KD is the cost of debt, multiplied by D over S. D for debt, the face value for debt capital, and hence our share capital. Okay. Now, I'll come back to these formulas later on when we're using that numerical example I was talking about earlier. And of course, I will again explain these variables and then addressing this. Now, how things change when we have that? Proposition number 1. The first proposition says that the value of the levered firm is equal to the value of the unlevered firm. Okay, so far. Plus something. Now, what is that something? That's PD. What is that PD? I'll just explain right now. Here we are. Right. What's different, that plus something, actually has to do with the tax deductibility of interest charge. Okay? That is our clue here. That is our key thing to remember and to focus on. The difference between the two companies, their value, comes from the tax deductibility of interest charge. Let's see. A tax bill is the amount of tax the firm would have paid had it not incurred the interest expense. Okay. Now, the annual tax bill is equal to interest rate multiplied by debt multiplied by the tax rate. Now, if we want to focus on the present value of that figure, then we simply have to use the present value formula, right? Now, what is the present value formula? Well, as you know, that the present value formula is equal to the cash flow over 1 plus I, the interest, the discount rate, okay, in the power of time and period. Huh? Yes, that is the present value formula. But in our case here, we regard this cash flow, this tax shield, as a perpetuity, as going to infinity, okay, as a perpetuity. And then what is the present value of perpetuity? Cash flow over the discount rate only. That is why we divide that numerator by the discount rate only, by the interest rate only.